The last video we did was isomers, part 1. And we just did isomers taking a methyl group off the end of one of the hydrocarbons and putting it somewhere. Okay? Now what we're going to do is we're going to do more than one methyl group taken off a hydrocarbon chain and naming those. And then we're also going to put a halide in there, like fluorine, chlorine, bromine, iodine, and naming those. And then I'll show you how to do double and triple bonds, naming those. Okay, so here we go. The first thing we're going to do is we're going to do an octane trunk. So here's an octane trunk. I'm not going to draw the hydrogens, it takes too long, but every one of those bonds coming off the carbons that are in black would be to a hydrogen. Remember, they're all single bonds saturated with hydrogens, so this has to be an alkane. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them, so this is octane. And that is C8H18. Remember the general formula for anes, double plus 2. Double the carbon number, so that would be 8 and 8 are 16, and then add 2, 18. Now, if we took one carbon off, that's a CH3, we can put it basically anywhere on there, but remember, once we cross the midpoint, we have to number it the other way. So what I'm going to show you is I'm going to show you when 2 are taken off, when 2 methyl groups are taken off. So if I take 2 methyl groups off, we go down to a hexane trunk. Now, we have 2 methyl groups to play around with. So I'm just going to show you a couple of them because this is going to be part of your bonus homework. 2 methyl groups. Remember, once you rip a methyl group off the end, you cannot put it on either end because that will be the longest carbon chain. So we can go like this. Let's put a methyl group right here. And let's just put a methyl group right here. Now, we put the 2 methyl groups, but now we have to figure out how to number it. Do we number it left to right or right to left? Well, this methyl group comes off the 2nd carbon this way. This methyl group comes off the 3rd carbon that way. So we are going to number it from left to right. 1, 2, 3, 4, 5, 6. So now we have that, and what we have is we have a 1, 2, 3, 4, 5, 6. We have this trunk. You always have to find your longest carbon trunk, and it's 6, so it's hexane. We have 2 methyl groups. So obviously it's going to be dimethyl, but we have to find out what carbons they come off of. 2 and 4. So this is 2, 4, 2,4-dimethyl hexane. That's what that is. And obviously you can have that one here, or you can have that methyl group on top. So there's all sorts of crazy ways, but the one I want to show you is the one we didn't talk about before. With a hexane trunk, if you have 2 methyl groups, you can do this. with two methyl groups, you can have an ethyl if you have a long enough trunk. So, an ethyl is 2-carbon branch, not a 1-carbon branch. Well, I tell you where you can't put it. You can't put an ethyl right here. Because watch what happens. I'm going to do it. There's your ethyl. But the problem is it's too close to the end. So this is not 1, 2, 3, 4, 5. It's not a 6-carbon trunk. It's a 1, 2, 3, 4, 5, 6, 7. That's a 7-carbon trunk because the longest carbon chain is this one. So, rule, if you're going to use an ethyl, it can't be off the end and it can't be off the 2nd carbon in from the end. All right, it's got to be in the middle somewhere. So let's try this again. All right, here we go again. Now I have 2 carbons, and I have either I can put 2 methyls around or I can make an ethyl. So remember, we can't put an ethyl at the end, we can't put it right there, but we can put it here. So let's put it here. Now, your longest carbon chain. Circle your longest carbon chain. Name your longest carbon chain. 1, 2, 3, 4, 5, 6. So it's hexane. And now the branch, 1, 2, 3. So your branch is coming off the 3rd carbon from this way. For this way, it's coming off the 4th. So this is the closest. So this name of this isomer is 3-ethyl hexane. 3-ethyl hexane. And that's one of your bonus drawings for when you make all the isomers of octane. So that's ethyl. Okay? Now, we didn't do any isomers for alkenes and alkynes. Really easy. So watch. This is very interesting because I never showed you how to do this. Watch this. Okay, now you've never seen it in this form before. The first thing you do if you see it in this form is count up the carbons and count up the hydrogens and see if it's an ane, ene, or yne. All right, so let's count. 1 carbon, 3, that's 4, 5, 6, there's 7 carbons. C7. Now let's count the hydrogens. 3, there's 6 there, that's 9, 10, 11, 12, 13, 14. Now, C7H14 is that double plus 2, double or double minus 2. In other words, double plus 2 are the alkanes, double are the alkenes, and double minus 2 are the alkynes. Well, that's double. So that just means there's a double bond somewhere. Now the next thing you do to draw this is to draw all the carbons in a row. And since we already know that there's 7, we do that. Now we just have to put in the H's. And I'm going to put in the H's for this one. So CH3, so the first carbon, we have 3 H's. The next 3 carbons, we have 2 H's each. 1, 2, 1, 2, 1, 2. The next 2 carbons, we only have 1 H. And then the final carbon, we have 3 H's. Now, my question is, are all the carbons satisfied? 4 bonds around that one, 4 bonds around that one, 4 bonds around that one, 4 bonds around that one. We only have 3 bonds around that carbon, and we only have 3 bonds around that carbon. And since we know it's alkene, then there is a double bond right here. So now we have them all. Now how do you name this thing? Well, we know it's 7 carbons and there's a double bond, so it's heptane. But that's not all you have to do to name it. If you just told a person, draw heptane, they wouldn't know where to put the double bond. So, rule, wherever the double bond, whatever end it's closest to, you got to number it that way. So this double bond is closest to that end. So we have to number this thing that way. So it's 1, 2, 3, 4, 5, 6, 7. So now you can tell the person, draw 1, 2, the double bond comes after the second carbon. So now you can tell the person, draw 2 heptane. And they'll draw 7 carbons, and then after the second carbon, they'll put a double bond. So that's 2 heptane. How would you make an isomer out of that? Easy. Put the double bond there. That would be 1 heptane, 2 heptane, 3 heptane. But remember, once you get to 3 heptane, here's the midpoint. Once you cross the midpoint, you got to number it the other way. So, isomers for this, 1 heptane, 2 heptane, and 3 heptane. All right, very easy. Now, the next thing we're going to do is I'm going to give you a name and you're going to build it. So we'll start with a pretty difficult one. All right, here we go. Okay, so now let's check it out. 4,5,5 trimethyl, 4-ethyl, heptane. So you draw the trunk first. It's heptane. So you have 7 carbons and it's A and E, all single bonds. Now, go like this. We can do that because we know it ends in A and E, so it's all single bonds. Now, where to put the branches? This is the trunk, heptane. 4,5,5 trimethyl. So now what we're going to do is, I'm going to give you a name and you have to build it. That's much easier than the other way around. Okay, so here's the name I'm going to give you. Okay, it looks really hard. 2,3,4 trimethyl, 4-ethyl octane. If you're going to build something, the first thing you got to do is you have to build the trunk first. Here. So you got to build an octane trunk, which means 8, and since it ends in ane, they're all single bonds between the carbons. All right. Now, the only reason I can put all those around it is because I know that they're all single bonds between the carbons. Now let's figure out what we got here. 2,3,4 trimethyl. So on the second carbon, third and fourth, we put methyls. Second carbon. Third carbon. Fourth carbon. So that's 2,3,4 trimethyl. Now, on the fourth carbon, we have to put an ethyl. Now, don't forget, an ethyl is 2 carbons in a row. So, now this one is 2,3,4 trimethyl, 4-ethyl octane. Pretty crazy. All right? Now, we're going to do one with a double or triple bond to show you. Okay, now 3,4 dimethyl, 4,5 diethyl, 1 octyne. Look at the trunk. The trunk is oct, so you know we have 8 carbons. All right, we got 8 carbons, but it ends in YNE, so we know we have a triple bond. But where do we put the triple bond? It says so right there, 1. So off the first carbon, we put a triple bond. So that is the trunk. Sorry, now that is the trunk. I only had 7 for the carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have 1 octyne. Now, if we look, the first carbon already has 3 bonds. So we only need to put 1 hydrogen there. Now it says 3,4 dimethyl. So 1, 2, there's 3. And there's our methyl. Here's 4. I can put 1 up here if you want. 3,4 dimethyl. And then 4, 5 diethyl. So there is an ethyl there at 1, 2, at 4. We put 1 at 5. And there is our 3,4 dimethyl, 4, 5 diethyl, 1 octyne. Remember, you have to build the trunk first, and then throw the branches on top of it. Okay? So, I'm going to give you one more, and this will also help you with your bonus for the isomers of octane. All right, so here's the name I'm going to give you. All right. 3-methyl, 3-ethyl pentane. Now, I said it's going to help you for the isomers of octane. Yeah, because look how many carbons there are. There's 1 carbon in a methyl. There's 2 carbons in an ethyl. That's 3 carbons so far. And then there's pentane, which is 5. That's 8 total. So how would I build this? The first thing I have to do is look at the trunk. It's pentane. 1, 2, 3, 4, 5. So there's the pentane trunk. There's no double or triple bonds because it ends in ane. So then I can go like this. Now, all I have to do is I have to put 3-methyl and 3-ethyl in there. So, off the 3rd carbon, there's a methyl, and off the 3rd carbon, there's a methyl. So I'm going to put a methyl right here. There's my methyl, and then I can put an ethyl down below it. So, there is one of the isomers for octane. 3-methyl, 3-ethyl pentane. Now, I'm going to give you one more hint about all the isomers of octane. Some of you will be able to do this, others you're going to have a tough time. So octane. Octane, you ready for this? Has 18 isomers. Now, 18 isomers. Now I'm going to break it down and tell you how many there are with each trunk. Okay, so there are 3 isomers with a heptane trunk. All right, there's 3 isomers with the heptane trunk. There are 7 isomers with a hexane trunk. All right, so there's 3 isomers with heptane, 7 with hexane, 6 with pentane. And there is 1 isomer with a butane trunk. Now, these add up to 17. Well, where did I get 18? The very first one, at normal octane is just 8 straight across. We count that as the first one. So, other than normal octane, here is the breakdown. Now, only the people that really understand how to do this should do this as bonus. Your homework after Memorial Day is just do the isomers of heptane. Now, the isomers of heptane, there are only 8 isomers of heptane that you have to do. And I'm going to break that down right now. Remember, this is bonus. Now, there are 8 isomers of heptane. Remember, you start with normal heptane. Now, there are 2 with a hexane trunk. Okay, 2 isomers with a hexane trunk. And then there are 5 isomers with a pentane trunk. So that's 7. And then there is 1 isomer with a butane trunk. So, this is your homework for Wednesday, okay? The 8 isomers of heptane. 2 with a hexane trunk, 5 with a pentane trunk, and 1 with a butane trunk. So, you have to build them and name them, okay? All right, so we're going to do one more crazy one, and then that'll be it. Three, 4, 5 trimethyl. For ethyl, 5 chloro. One, I don't have enough room here, so I'm going to put it down here. 1 nonene. Okay? So rules. This looks huge. 3, 4, 5 trimethyl, 4 ethyl, 5 chloro, 1 nonene. So we know non, got to have 9 carbons. It's ENE, so that's a double bond after the first carbon. So there's a double bond after the first carbon. Now, 3, 4, 5 trimethyl, that's 1, 2, here's 3, 4, 5. Remember, you can put them on top of the carbon chain or the bottom, it doesn't make any difference. 3, 4, 5 trimethyl, 4 ethyl, 1, 2, 3, 4 ethyl. That's a 2 carbon down. All right, and then it goes 5 chloro. Well, chloro stands for chlorine. So 1, 2, 3, 4, 5 chloro Cl. Now, I didn't put any of the hydrogens, but that crazy thing right there is 3, 4, 5 trimethyl, 4 ethyl, 5 chloro, 1 nonene. All right? Okay, good luck.